I'm Stuart and I'm one of the security engineers at Check Point, and this video is to give you a quick preview of something that Check Point are working on called Infinity Next, and specifically one of the services within that, Web Application and API Protection, or WAAP. If you've been to any of our CPX events in the last couple of years, you might have heard us talking about Gen 6 security, or specifically nano agents. A nano agent is going to be a small multi-platform software agent which can be installed on anything which requires security. So it might be a cloud workload, a web server, a smartphone, or an IoT device. Each of these agents will have a specific function, such as protecting against OWASP top 10 style attacks, API protection, scanning for and virtually patching firmware vulnerabilities on IoT devices, and even firewall controls. Each of these agents will be controlled via our Infinity portal for central management and reporting. Deployment can be integrated in a number of ways, such as including the agent in a base build of your workload or container or web server. Then, once it's deployed, it will update itself with relevant modules, similar to how our endpoint agent works. And depending on the configuration that the nano agent receives, it will configure itself to give that type of protection. So let's have a look at how it currently works. Currently being the keyword here because it's only available for customers who have joined our early availability program, and it's still under active development. So a bit of a disclaimer if anything looks like it might not be quite finished yet. So this is the main overview that you will see when you log into your Infinity Next portal. You can see here a number of controls that you can enable or disable depending on which agents you want to deploy. You simply turn on the agents you want to use and ignore the rest. The one we're going to look at the moment is Web Application and API Protection, which is covered here by the public and private cloud asset types. The WAAP agent is effectively a WAF, but far easier to deploy and configure. Plus, there are additional transparent protections leveraged from ThreatCloud, our global intelligence database. So on top of the features like OWASP top 10 style protections against SQL injection, cross-site scripting, command injection, it gives you the power to enforce strict control over your APIs using the API standard. So if, for example, you had an API which only accepted numbers and an attacker tried to perform a SQL injection attack, it would detect that there are non-numeric characters in the requests and it would block it instantly because it knows it doesn't have to apply any advanced protection. It can say, this doesn't conform with what we're expecting in on the API request, we're going to drop it. So it's a very simple way of enforcing what you expect to be consumed within your API rather than having to say, look at more complex behavioral analytics. So on top of that, there's also Taboc Technology, which is a bit different to the Taboc technology that you might be familiar with from our security gateways and our endpoint clients. This works by detecting scrapers and other web-based bots that might be accessing your application in a programmatic way, looking to scrape user data or contact data or any other data that might be used against you in a later attack. Plus, it does have the more traditional anti-bot type protection, again, leveraged from ThreatCloud to say, if an IP address is seen connecting into your asset, or on that later, then we can allow or deny it if we know that it's bad or not. So if we've got an indicator that says that an IP connecting in is from a botnet or something which is distributing malware or a host used for phishing, we can instantly drop that because we can say that's a malicious IP address, we don't want to be using that, we don't want that connecting to our asset, whatever it might be. So when you have decided you're going to use this, you want to first go and configure an agent. The agents are a minimal client that are installed on your device, whatever it might be. So it could be IoT, it could be mobile, it could be a web server, it doesn't matter at this point. The one we're focusing on for now is WAAP, but there will be other agents coming in the future. So the first step is to define your agent's profile. And after the agents are deployed, they will talk back to the Infinity Next portal and present a token. You can configure a unique token per device if you want to. So if you were ever in the situation where you had to revoke an agent, you could do that very easily. Or if you wanted to roll out a load of agents en masse, you could use a single reusable token across all of the different agents. They can configure themselves, or they can be configured rather, to update automatically, or if you want a little bit more control over it, the agents can be updated manually. So you would log onto the agent or do it via some sort of automation platform and trigger the update to occur. So in a similar way that you might log on to your security gateways and update manually, you can do that with the agents as well. The preference would be to update automatically, because you can ensure that they're always going to be running the latest version of the agent, and they're going to have the latest functionality, the latest modules, the latest intelligence, etc., etc. So once you've configured these, you can see all of your agents that have been deployed, which of their unique identifiers they've got, what host they're installed on, when they're installed, and when they're last connected, and also where they connected from. So this doesn't have to use a public IP address. If you've got something that's in a private environment, not sure why you'd have that for a web asset, but if it was for staging or development, that would be able to talk out to the platform provider that had internet access. We don't need access to the agents, it goes from the agent to the portal. And you can see here the version number as well, so you can see if you've got any agents that need updating at all. So you've configured your agents. The next step is to configure your assets. So an asset is what the agent is protecting. In this case, it's going to be a demo web server. You configure the host name, the URL, the port, and whether it's production or staging. The staging properties here are used to define where that application or that asset sits in your network. So you can build a strict policy up that says I've got these different zones for my application, or different tiers of my application. So you might want to define something that says on the outside you've got your web server, that can talk to a middle application tier, that can talk to, I don't know, something else, and then that can talk to the database, loosely like we've got in the example here. So you can get firewall protection with the agent without having to deploy a perimeter gateway, which is quite different for Check Point, seeing as a lot of our heritage is around security gateways. So we've defined our agents, we've got our assets configured. Next we want to look at our policy. So you should feel quite comfortable with the policy, because this looks and feels and behaves a lot like the standard policies in Smart Console. So instead of configuring ports, services and hosts, we configure what we call practices, which I guess are loosely similar to best practices. So you might have a best practice configured for web applications, one for APIs, one for zones, and then as more agents are introduced, we'll have best practice for IoT, for mobile, and for other services. So here you would look at, let's look at the web application best practice. You can see here you've got a number of drop-down boxes that define your policy. So you can choose whether to protect against bots, you can choose web attack mitigation, you can choose whether it's in detect mode, prevent mode, or if it's in learning mode. Learning mode refers to the agent itself. The bulk of the protection is done via machine learning on the agent itself, so it has a scoring system to determine which attacks are legitimate and which ones have gained a poor reputation. So if somebody goes into the landing page for your site, the root page, and they click around and they navigate in a normal behavior, that will be fine, and most of those requests will get through. If, for example, somebody tries to access the admin page directly, something which isn't publicly accessible, we can immediately flag that as malicious or suspicious behavior and start building up a score gradually to say if the score gets to a certain threshold, then we're going to drop anything from that particular client. You've got other protections in here as well. So if we look at the threat prevention, we change the type from internet, you'll see here some hopefully familiar categories: no malicious IPs, anonymizers, high-risk countries, and malicious files. All of this stuff is coming from ThreatCloud. So based on IP reputation or other intelligence that we've got on that host, we can allow or deny those connections on top of the intelligence that we're applying from the agent itself, which is doing the machine learning and the scoring for the connections that are coming in. API protection, this is where you would define your schema for your API. So if you had a document that says what your API will do, basically what types of inputs it has and even what types of outputs it has, if any request or response wavers from that, you can automatically drop it. The response is quite interesting, because if there was something that did manage to get compromised, but your response validation said we're not expecting any database to be thrown out for this particular request, that can drop it as well. So it's quite a clever way of applying a strict control to your web applications, in particular APIs. So once you've got your practices defined, you put those together into the policy. The policy combines the assets and the zones, so your web server or your agent, then the practice on top of that, and then what you want to do to it, whether you want to log it, or if you want to trigger something else like a Slack notification. It's all very simple, and the goal of it is that, especially for WAAP, it's meant to be a lot easier to deploy and a lot easier to maintain than a typical WAF, which, having spoken to a number of customers about WAF experiences, some of them end up just completely not using the WAF at all. They spend so long in pre-production or rollout and spending a lot of time and effort on the learning phase that it's not worth deploying. WAAP is meant to be completely different to that. You install the agent, you define a best practice, and you let it go. The machine learning on the agent takes care of all of the security concerns and the tuning of the policy, and then if necessary you can override it with particular tweaks around certain parameters or certain ways that the application behaves and ways that the machine learning algorithm doesn't quite detect. But those are a minimum, and the results that we're seeing back from the early availability and the trials with our customers are very promising, and we're seeing some really good feedback from customers that have got it deployed. So if that's something that you're interested in, please let us know. Speak to your partner, your reseller, or your account manager, or your security engineer at Check Point. Hopefully that's been interesting, and speak to you again soon.